Hey everyone, in this video we're going to cover secrets management, or secret management really, even though there's logs management over here. I don't know whether to use the S or not. Either way, let's talk about secrets management. So really, engineers weren't trusted enough to store sensitive information. And why should they, right? We have people that are committing secrets to GitHub in clear text, people that are leaving servers wide open. We really can't trust engineers across the industry to manage secrets. So we need secure handling and storage and practices to manage secrets on our behalf. Why is this important? Well, it's important because the applications that we build and that we run, they manage and work with sensitive data, right? They get passwords from users, they get other sort of sensitive information from users, API keys or whatever. And we have to protect that data, otherwise attackers can use it for malicious purpose. And so this concept of secrets management is a thing in the sort of the DevOps space, in every space really, but in the DevOps roadmap, so that we can keep secrets kind of out of the application. So there's going to be two sort of things to this that I'll go through later in the video, but we want to keep secrets out of the application and kind of get them in a just-in-time way so the application stays secure and there's no sort of like, oops, I accidentally committed secrets to a public repo or something. There are a number of secrets management platforms or tools. So first and foremost is HashiCorp Vault. This is the one we're going to cover here. So HashiCorp Vault is an open source, or now it's source available, I guess, with the license change, whatever. But it's a source available secrets management tool developed by HashiCorp and now IBM. And it's more than just like a key value store, though, even though I'm going to only show you the key value store in Vault. Vault supports integrations with other platforms to do like just-in-time or dynamic secrets, which is really nice, and like transit secrets where you kind of just give Vault data and it encrypts it and gives you back the encrypted data, right? Really, really nice features. We're not going to dive into those, but we'll showcase it. But Vault is a really, really widely used one. You can download Vault and use it locally. It's very fun to play with. And now if you don't want to deal with the HashiCorp IBM licensing stuff, there is OpenBow as well as the open source equivalent. There are other things as well here. There are like operators for Kubernetes, like the sealed secrets. There's other external secrets operators to allow you to get secrets from like third-party secrets management tools like AWS Secrets Manager or even 1Password or whatever. There's SOPs, so secret operations. I haven't heard about this until I just clicked the roadmap, not gonna lie to you. So I'm not even sure what this really is. If this is like I guess it's an open source tool, but there's this. And then each cloud provider has its own secrets management tool, right? AWS has Secrets Manager, Google Cloud has Google Cloud Secret Manager, and Azure has Azure Key Vault. So basically, like a secrets management platform, a glorified key value store, if you will, integrated into the cloud. Let's see how this affects our application, though, because that's kind of what we're here for. So let's go in there. So right off the rip, I have a Docker Compose file. So I have a bunch of files in here. Let me just show you kind of the lay of the land here. I have a Docker Compose file here, and this is going to run HashiCorp Vault. It's going to initialize HashiCorp Vault by writing some secrets into it, and it's going to run Postgres. And it's going to initialize Postgres with some like example table so I can show you. Now, for a second, I just want you to, for this part, I want you to ignore Vault for a second because I just want to show you what life looks like without Vault. So outside of this, we also have this environment, which we'll come back to. We have Go mods, whatever. We have the Postgres. This is the table that we're creating, right? So we have just a users table with 3 records in it. The Vault setup is putting some key value, which we'll cover later. And the main.go is really what I want to show you. So I have this main.go. And all this is going to do is going to connect to Postgres using these secrets that are inside my application, right? Notice how I'm putting the secrets inside my application here. So this is not a good practice. You would probably want to do like os.env or sorry, get env and like read like, pg, pass or something like that, right? Read a variable from the environment. That's more secure. But I just want to show you like, this is the before secrets manager sort of process. So I'm connecting to Postgres. Once I get a connection, I'm going to print out all the users, right? So pretty simple Go program here. You don't even need to see connect Postgres and you don't need to see print users because all it is connecting to a database and then running one SQL query. So there's not really much there, even though they're at the end of this file. Okay, so let's quit that. I need a Postgres to connect to. So I already did this with Docker. So I'll do Docker Compose up -d to run it as detached, right? and I'm gonna wait for my containers to start. Really, all I care about is Postgres here. I don't actually care about Vault right now because I'll show you that later. But now that Postgres is running and it's initialized with some data, we can do go run and we can see, boom, my program can connect to Postgres and fetch those 3 rows from the users table. Great. This is what life is like without secrets management. You have potentially insecure, sensitive data in your application, which is a huge, huge, huge red flag, right? And you could probably say, okay, Matt, well, I'm going to do, password equals os dot get env, and we'll do PG pass like I showed you. This is perfectly fine. Like you could totally do this, and then you change this to password. Oops, sorry. You change this to password, and like everyone's happy. You can totally do this. But now you have to remember every place that you run this application, you have to pass, pun intended, I guess, you have to pass this PG pass environment variable to your application, which means how are you getting it there, right? Are you giving your developers these secrets and then trusting that they're going to use it correctly but via the environment variables? Are you storing them as like Kubernetes secrets or something? Are you just, what are you doing, right? Like, what are you really doing? Are you putting them clear text in the application? All of those have their pros and cons, right? Instead of doing that, we kind of use a secrets manager in the field. So there's 2 sort of ways we use a secrets manager, like platform or tool or whatever in the field. One is to get secrets at runtime to connect to our dependencies, right? This application here that I'm running, that I'm showing you, this Go application, it has one dependency, and that is Postgres, right? Because the application needs to run, connect to Postgres, and print out users and do whatever it needs to do. So this application has one dependency, Postgres. Now, if you wanted to add a secrets manager here, like Vault, which I'm going to show you, you have to remember, and this is something that everyone that covers secrets managers or whatever, they like fail to mention this, and it kind of gets me a little angry. The second you add a secret manager into your platform to get these just-in-time secrets to connect to your dependencies, you add another dependency, right? So let me delete this main function because I have another one right below, and I'll uncomment to that one out. So I have this other main function here. So I will just uncomment this and we'll talk about it. And I'll just do that. Perfect. Oh, I did that backwards. Ha. All right, let me do that a different way. Sorry. Ah. Oh, I thought I was going to go to the bracket. Oh, sad. Okay, let's just do it this way. You're going to see me hit the wrong keys for a while. Perfect. Okay, so I have this other main function here. And this is, instead of me having to read the Postgres, credentials, whatever, from either the environment or just hard code it in my file, I'm now storing them in Vault and I'm reading them from Vault. So when my application starts up, the very first thing it's going to want to do is it's going to want to create a Vault client so it knows how to talk to Vault. Again, how do you pass this to your application? Usually you do this from an environment variable, whatever. Then from there, it's going to read all of the secrets it needs from Vault. So why is this better? Well, instead, like let's say your application had 3 dependencies and each of those dependencies needed like a username and password to connect to, right? Maybe it's Postgres, Redis, and like S3 or something. It doesn't really matter. Now your application is responsible for 3 different credentials. So if you pass them via the environment or whatever, or some configuration file, you're responsible for keeping those credentials safe. Instead, if you use something like Vault, you can put all those credentials into Vault. And then when your application starts up, you can read them just like this line here. You can say, hey, read my Postgres secrets, read my Redis secrets, read my S3 secrets, and let me use them to connect to these downstream services. But again, like I said earlier, you add a dependency to your application, which is Vault. And you might be like doing this sort of logic in your head when you're saying, wait a minute, Matt, I was responsible for 3 different credentials, right? Postgres, Redis, and S3, but now I'm only responsible for 1 credentials, which is to connect to Vault. Isn't that like fewer dependencies? It's fewer secrets that you're managing, but you still have 4 dependencies. You depend on Vault to get the secrets, and then you depend on Postgres, Redis, and S3. So just keep that in mind. Again, these are everything in this field is trade-offs, so you just need to know these trade-offs when you're working with them. So this is an arguably more secure setup here because now I just create a Vault client, and I do that by reading the Vault address and the Vault token. So the only secret my app has to care about now is the Vault token. And it's much easier to manage one secret in my application than to manage 3 of them and potentially have 3 different doors that an attacker can enter. So I create that Vault client, read the Postgres secret, pass all of the information from Vault, the username, the password, all that stuff into my connect Postgres function. I connect to Postgres, print the users as normal, and then I'm going to format that code. And then I'm going to run a second loop to show you sort of the second way that you can use secrets managers in your application. So let me run this first before I talk about it. So now here I'll do go run again. So this time you'll notice that I'm gonna kill this real quick just because I want to talk about it a little later. You'll notice now instead of my application having the Postgres information, via hard-coded or environment, I have read it from Vault and then I've used it to connect to Postgres. This is the first way that applications use something like Vault, is to get credentials for the application's dependencies. And now if I open up a new tab and I showed you like Vault KV get, if I fetch the value from Vault myself, oh, not user, sorry. That's the one I want to show you later. Postgres. If I showed you the Postgres stuff, you'll see like in Vault, the Postgres information is stored safe and sound. That sensitive password here is there for my applications to use, but my application doesn't have to read it clear text from like an environment variable. Much, much better security. Okay, going back. Now, I showed you real quick in the code at the end here, or at the end of main really. So let me go down here and go to main. Yeah. So I showed you in the code here that not only can you use Vault or some secrets manager to get your credentials for your dependencies, but the second way you can use it is to actually store application data. So let's say like this was an API, right? I didn't want to write an API, like whatever. Let's say this was like some sort of API or some sort of service that a user would connect to like, store information. I don't have to store that information in some like database or whatever. I can store it in Vault and it keeps it secret. It keeps it encrypted on disk and all that stuff. So to do that, to simulate that, I'm just running a loop every 3 seconds and I'm creating a Vault client and I'm saying, hey, connect to this specific Vault backend. And I'll talk a little bit about how Vault works towards the end, but I'm connecting to this specific Vault backend, right? I'm using the KV store and I'm connecting to the secret backend. And then I'm looping 3 times. And each loop, I'm just upserting a secret named user. And I'm just simulating like this user data changing, every 3 seconds, like, someone coming to my website and doing something. So I'm going to run this again. And that's going to start iterating, right? Iteration 1, every 3 seconds, iteration 2, yada, yada. If I actually use the Vault now to get the user secret, you'll see that the iteration is 4. If I run it again, the iteration is 5, and so on and so forth. This is that second way that applications use Vault. They use it as like some secret storage location for application level data, right? Not just for credentials to get access to dependencies, but for application data. So there's sort of 2 ways that secrets managers are used: to gate credentials for dependencies and to store actual secure application data. Both are perfectly fine. And that's what I wanted to show you here, because quite frankly, you shouldn't be keeping anything sensitive in your application. You should be reading things from some sort of secure secrets management location, especially if you're working at a company where you're writing hundreds of apps or whatever, because now your security team has to manage secrets in one place. Imagine if they had 100 apps with 100 different credentials for 100 different things. They had to manage those credentials and give them to each app. That would be a nightmare. Instead, if you tell all of those 100 apps, hey, go to Vault to get your credentials, right? Like, this Postgres credential, like go to Vault to get your Postgres credential for each app. And you can do it so each app, like, had app 1 Postgres or app 2 Postgres or app 3 Postgres. You can do it like that. This is where those backend paths become important. But if you have that architecture, now your security team or whatever only has to worry about keeping Vault safe and secure. But like I said at the top of the video, now Vault becomes a critical point of failure, right? So if for example, if Vault is down and your application starts up or has to restart and it can't read that Postgres data, well, now your app's going to fail. So you've just created a single sort of point of failure in Vault if you're not careful. And this is why you run like something like Vault in a clustered scenario and blah, blah, blah. But there's these trade-offs here, right? You can't just get security and availability and everything for free. There are trade-offs you have to make. And I just want to kind of show you that. Okay, So before I end, I just want to show you a little bit about Vault. So Vault has like a backend called KV, right? This is the Vault's key value store, and each key value store, like each key essentially that you store in Vault, has its own sort of like mount path. And if you want to like give different things different paths, you can do that. And that's actually really, really nice because it allows you to kind of segregate your applications based on these sort of paths. And I guess Vault, changed the wording to this to be mount instead of path. I don't know. I'm not as I'm not as like up to date with all the Vault terminology, but back when I used it, it was like, path like syntax, I guess, whatever. Either way, you can segregate your secrets based on like application. So like, for example, if you mount a secret in one place, you can give it one policy so that only one app can read it. And if you mount a secret in another place, you can give it another policy so another app can read it, which is really nice because now like if one application does get compromised, you don't lose all of your secrets, which is really, really nice. And again, like this assumes that you're following the mindset of like one secret per app, which you should be. But either way. And then outside of this, so I'll do Vault help. Vault has, its own client and server, right? So the Vault client and the Vault server are here, but it has different backends or different, secrets engines, I guess you can call it, that you can use. You have the KV, right? So KV store. You have PKI if you want to like manage your public key infrastructure, right? So like your private public keys for TLS or whatever. You have the transit backend that I showed you, or that I talked about. Sorry, I didn't show you, where you can like give Vault clear text data and it can give you encrypted data back, and vice versa. It can decrypt it for you. And then there's other like dynamic ways to connect to Vault. And actually, let me go in here and I'll do hashicorp.com and I'll go to, I guess, products Vault. Yeah. And I wanted to show you real quick because this is actually pretty nice. I don't actually know where the docs are for this anymore. Everything's changed. Everything's changed. Not only do you have like these different secrets engines. So look at this one. I want to show you the one for databases. This is a pretty nice one. Each engine like is a type of way to, store secrets, right? So the most popular one is going to be like the KV store. That's like Vault's bread and butter. But you can also have transit and everything I told you about. One that I really like, and one that I wanted to show you in this video, but I just don't have the time. I have a baby coming soon. One I wanted to show you is a database one, and I'll just click the Postgres. So in the example I showed you earlier, I stored Postgres data in Vault, right? In a key value store. I gave it the username, the password, all of that. I actually didn't even have to do that. Vault has this integration called like a database secrets engine. And instead of me storing like instead of me storing credentials for Vault in the key value store, I can connect Vault to my database. And what Vault will do is it will dynamically on the fly create me a database like user and like password essentially, right? Credentials. It'll dynamically create me credentials that my application can use on the fly. And those credentials expire after a period of time, so I can renew them. And I never need a user or password again. I could just use these credentials dynamically and keep going. Again, much like anything else that's stored in Vault, it becomes a dependency of your application, and you need to make sure it's up and running for you to use it. But like super, 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 super powerful if you do all of this correctly. And I think that's about it. I really wanted to make this one quick, and we're about to be under 20 minutes, so this is great. But just to like kind of give you the rundown again, if you're wanting to store, securely store secrets for your application, don't just put them clear text in your app. Environment variables are okay, but then remember, if you have different dependencies, you have to have like all of those different environment variables. If you have a secrets manager like Vault or AWS or GCP's versions, you can use that. But then Vault becomes a dependency and you have to take care of that. And that's really all I wanted to show you. I mean, there's so much more to talk about in Vault and secrets management and all of that. I really don't have the time to get into all that. I just want to kind of pique your interest and show you like, here's different things you can be doing in your application. If this interests you, or if this is like, hey, I kind of like this flow, go dive in. It's like super simple. Let me do a Docker Compose down. It's really simple to run Vault locally. You can do Vault server -- dev and boom, Vault is running. And that's it. Like this is it. This is all dev creds. And like, I don't have to do anything else except for like export this environment variable. So if I do that real quick, so, m dot vault adder equals, what is it? This, sorry. Yeah, get rid of that real quick. And then I can do vault login. It's going to ask me for that token. Just grab this beautiful token right here, paste it in, and boom, I'm authenticated to Vault. Like, that's all you need to do to get started. There's nothing preventing you from starting with Vault. And then now from here, I can do like, Vault KV, and I can like, put something in, put secret foo, and then like whatever the data is here. I don't remember how to do the data off the top of my head. I don't really use the CLI so much. There you go. I'll do key value. Perfect. Oops, so sorry. Name equal Matthew. Boom. Now I've just put data into Vault. And now if I do Vault KV get secret foo, boom, there's my name, Matthew. Like, that took me what? 30 seconds to do all of that, to start Vault, to log in, to put a secret in. Like, you can do that too. Play around with Vault, see how that can interact with your application, and have fun. And with that, I am really running out of time. Sorry, I meant to record more of these videos. Like, here, I'll put the talking head on. I meant to, like, I mean, you can see my room. Look at the room. The room, I don't even know. The room is a disaster. Baby's coming in like a week or two. I'm busy. It's been busy. So I haven't had the time to I wanted to get ahead on these recordings. So I do want to finish the DevOps roadmap, and I want to get everything good and recorded for everyone. But I wanted to get ahead on some of these recordings, and my work has been busy. After work has been busy. The weekends have been busy. So everything's been busy. So yeah, but I'm still committed to finishing the DevOps roadmap. I just want to let you know, if you see me like running through it or whatever, or trivial examples, it's not because I don't want to, or I don't know these things, or I don't want to talk about them. It's just time. It takes time to come up with like these examples and to explain them correctly. And time is not something that I have a lot of right now. So forgive me for that. But if you have any questions about this stuff, like, I'm happy to chat more about it. I mean, I use Vault pretty extensively in previous roles. I don't use it in my current role just because like we're not, Oxide is not like a SaaS company where we have like all these services running all the time and needing secrets. We are like, we ship an on-premises product where like, the apps go out there. So we don't have these sort of like SaaS services, but I use Vault for like other home labby things, right? To store my secrets. And when I say I use Vault, I really mean like I use 1Password, because, I use I use one of the secrets operators to read 1Password data, and that works pretty well. So I treat 1Password as like Vault's key value store. I should probably be using Vault or OpenBow or whatever to like do more of the PKI stuff and like other things. But again, like, setting all that up is time. But anyway, sorry. I already rambled on enough in this video. Thanks for watching, and I'll see you in the next one. Hey everyone, I just wanted to have a quick little addendum here. So I didn't mention anything about this Unseal key for Vault, and this is a Vault specific thing, but basically when Vault is running, when you run Vault for the first time, it's going to give you Unseal keys, because Vault needs to encrypt the data. So you need some sort of way to encrypt the encryption key that Vault is using, right? And that is by way of an Unseal key. So the Unseal key is just a number, one or more keys that Vault can use to encrypt the encryption key it's using. And in the development mode, there's one Unseal key. In a production mode, you would probably shard this into 5 Unseal keys, and then you would need like 3 out of the 5 to reconstruct the actual, encryption key, and using like Shamir's secret sharing algorithm, whatever. Point I want to make here real quick in the addendum is that when Vault is running, it has to be unsealed to be useful, right? The Vault has to be unsealed to read what's inside. So when you stop Vault and you restart it again, it's going to come up sealed, and it's only going to unseal when you pass in the correct unseal keys, right? If it's just 1, or if it's 3 out of 5, or whatever you've configured it for, it'll only actually unseal and be usable once you unseal it. There are things that you can do to auto unseal it by passing it into some like, trusted, environment or whatever, but usually you have to put the unseal key in. So just keep that in mind. This is very, 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 very important, because when you do create a Vault, a server or a cluster or whatever, and then you put apps that rely on it, and then Vault has to go down for maintenance or something, and you don't have the Unseal keys, you can take down a lot of your infrastructure. And I've seen that happen at places. I've been paged for that at places. Just letting you know, quick addendum. Thanks all. See you next one.